Board. Okay, so we are recording, and now I'll share again. Okay, so let's make a drawing of this thing, and then we're going to go back in and we're going to modify the attributes. So I'm going to do make drawing from part, choose my drawing template. It's going to bring in a bunch of somewhat badly aligned views, but that's okay. So I'm going to arrange the views the way I want them. I only need as many views as are required to fully define the object. And let's see, I'll make a new isometric. And okay, so I'm not complete, but I'm looking down at the bottom going, it's probably not called my cool part. Might not be. Okay, so I want to go back to the attributes in the model, and I want to fix that so that my title block updates. I come over to my drawing manager off to the side. I go to one of the views, any view, it doesn't matter. I hit the little triangle so I can see the model that's being described. I right click and say open part. And it brings me back to the model that's creating the drawing. I'm going to say File, Properties. I go under the Custom tab, and here's all my information. So the part number, let's say the part number is 9876. The dash for the initial revision, that's fine. The description, let's say it's girder aluminum. Always remember, all capitals, never lowercase. I'm going to say I make this at my own company, so there's going to be no vendor or vendor part number. Okay, so that looks good. I'm going to say OK, save it, and I'm going to exit out of the part.
You said File, Properties, then Custom, right?
Correct.
Okay.
Okay, and as soon as I go back to my drawing, after modifying the model attributes, my title block updates, at least as far as the description, which is the drawing title, the part number, and the revision. To finish making the changes, I'm going to zoom in. I'll double click on the date. And let's see, today is 10/1/2020. The views are half scale. And this will be sheet 1 of 1 in the drawing. Green check, save it. There we go. Title block's all up to date.
Does the slideshow for this lesson include like an exact rubric of what you're looking for? So I could go down, after I do mine, I could go down through and do like a checklist?
Absolutely. I've got a checklist right on the website for that. In fact, let me show you that right now. That is an excellent question. I really am glad somebody mentioned that. And I will go through the rubric several times. So if we come under print example, So there's your rubric right there. Text in all caps. Views must always be aligned according to glass box. No text or graphics under the revision block, which is this thing. Fill out your title block. No double dimensioning. Dimension from a surface that the machinist can physically touch with either calipers, edge finder, something like that. Make sure your holes have proper callouts like this. Always make sure you've got a material with an alloy number. I don't ever want to see just aluminum. There's probably 150 different aluminums. And, you know, 1000 series Coke can aluminum is way different than 7075, which is used in the AR-15 lower receiver. Okay. If you're going to paint it or anything like that, put that right up in the notes. Always make sure your holes have center marks, the little bullseyes. Make sure they have center lines when in profile. That means this thing right here. Make sure your hidden lines are always turned on in the orthographic views. That means this one and this one. Those are the glass box views. Make sure your hidden lines are turned off in the isometric. And always have cosmetic threads. I don't ever want to see any spirally threads taking up the whole screen. Okay, so there's your rubric for piece parts.
I know when we were doing it in class the other day, I was struggling. I was obviously using the wrong technique to try to select the hole. So you know how we said the crosshairs in the hole. I was trying to do a smart dimension from the middle of that hole to the edge so you could place it, but I wasn't able to select the middle.
Okay. I do have another example of that. And if you want, I can share the example parts with you guys.
Yeah, sure.
Okay. Let's see. Let's see, what's the best way to do this? $120 lessons, we'll go down to 10. Call this let's see, CAD files. Thought I put this right on my desktop.
The graders must still be working on grading last week's homework, I would assume. I haven't got my grades back for it.
Okay, so if you guys go in lesson 10, you should see the office hours models and download examples 1 and 2. Then you'll have what I'm working on. Yeah, I haven't checked in with the graders lately to see where those guys are at. I pushed them kind of hard to get everything back before the exams. Wouldn't surprise me if they're having to work on their own studies now. Okay, so we'll save this one for so real simple part, but I think this will be good for picking on edges and stuff like that, putting in hole callouts. Okay, so we're going to do make drawing from part. We'll get rid of that awful tapped hole call out. And we're getting rid of it because it doesn't have the tap drill. It's got lowercase. It's just a complete abomination. Not that I'm biased or anything. Get rid of that isometric. Okay, guys, so which one do I want to have as my front view? Which is going to be front and center on the print, and why? What do you think, Patrick?
You want the side view to be the one. Yeah, you want the side view, right?
You're saying I want to call this my front?
No.
So I'm kind of liking this one.
Yes. Yeah.
And the reason I'm liking that one is it has the least number of hidden lines in it. And this part really doesn't have a defined front, whatever that would mean. Okay, so I'm going to go with the least number of hidden lines as the front. So let me get rid of this. So then if I want to call that the front, then I'm going to project my views off that. So I'll go Insert, Drawing View, and then Project it. Project that up. Project that over. So this is the one that's front and center in my view screen. Okay. Generally, what I like to do when I start off dimensioning a part, the question that I always ask when I go over to the material rack is, how big a piece of metal do I need? You know, how big a piece do I need to get the part that I want out of the chunk of metal? So I always start with the overall dimensions. So the height, and in this case, diameter. So that tells me what I need there. So I see a hole going down through the center. Let's put in a hole call out. So that's under Insert, Annotations, and Hole call out. Okay, something looks weird. So what's bugging me is that I'm not seeing the dotted line around the circle to indicate that there's threads there, and that this is saying that that's a coarse thread. Let's just delete that and see what happens. So right here, I see a dotted line around the circle. So this should be just fine as a thread. So Insert, Annotation, do the whole call out on this one. Okay, I buy that. But I could have sworn I made this one as just a plain old drilled hole. That's weird. Why is it doing that? That is not the tapped hole, people.
Just a quick side note. I know that
Yeah.
when we went over this in class, when we imported the homework on there, it was a 2-to-1, I think. Yeah, it was big. And then you put it down to a 1-to-1. When I
Yep.
was doing it in class, I put it to a 1.5-to-1. Now, do you want it a 1-to-1? The 1.5-to-1 seemed to fit closer to like the example one that you put on there. But
I mean,
I'll do a 1-to-1. I don't care.
it really doesn't matter. So the deal is you want to make it as big as you can so it's a nice, comfortable, readable print without making everything look scrunched up. I do not understand why SolidWorks is screwing up right now. I am not getting that. There should be a 1/4-inch drilled hole right there. And then this one should be the threaded hole call out that I see.
Would that be an error in the sketch, do you think? Yeah.
Yeah, let's go back to the model and see what's going on. See if we can figure that one out. Oh, no. No, they are both tapped holes. But why didn't the dotted line show up? I got the dotted line here. I don't have it up there. What is going on? It says bottoming tapped hole. I don't know why that would make a difference. With thread callout, cosmetic thread is turned on. Did it seriously do that because of bottoming tap? I mean, bottoming tap absolutely does not. Oh, that is weird and very wrong. A bottoming tap just means that there are fewer tapered threads on the cutting tool. It has nothing to do with the thread that's actually formed. Weird. All right, but whatever. That is really weird. But okay, whatever. Got to the bottom of it, right or wrong. So if I just put a dimension on that, I only get the tap drill size. So we'll do insert, annotation, and hole call out. So we get everything there. Okay. I'm going to drag the center mark out. And I'm doing this because this is a cylindrical face. Cylindrical faces always take center marks. Okay, because this thing is a cylinder, we're going to want to put a center line on it. There we go. And when I see the center line and I see this hole going right through the center line with no dimension, it tells me it's centered. Okay. So that's how far down to put the hole, the overall height of the cylinder. I haven't put any dimensions on this thing. So if I don't have any dimensions on it, and it's not adding to the story, I can just get rid of it. I will add my isometric. So insert, drawing view, and I'll project right up there. Whenever you're putting in the isometric, be sure to remove the hidden lines. And we generally use a smaller scaling on the isometric.
Is there a rule of thumb for that? Like half of the other size or just whatever fits? Or
Whatever looks good. A lot of times I do half. But again, it's just what looks good. Okay, so what was our material? I need to go back to the part. So that was another 1010 steel part. So I'm going to put a note on there. So I'll click on the note button. Good old 1010 steel, the stuff I buy at Bangor Steel. And so that's all the graphics that I need. That's the material I need. I've gotten rid of the second sheet because I'm not using it. That's good. So the only thing I need to do now is fill in the title block. These are all the defaults for my part template. So I'm going to go back into the model, go back to the attributes under properties, and the part number will be whatever you like, 4567. The rev will be a dash for initial release, and we'll say, I don't know, coupling, comma, shaft. Well, that sounds good. And we'll pretend we're buying it from McMaster-Carr. Always save it, get out. We'll do the last touch-ups on the title block. 10/1/20, today's date. See, I think I did 1:1 scale. And there's only one sheet in the drawing, so it's sheet 1 of 1. Nope, should be 2:1. I got that wrong. Always save it. Okay, sure, go ahead and update. And that's what I'd be looking for in a homework problem, folks.
So when the 0.5 you got there to locate the hole in the side view
Yes.
or the front view of it. So
Yes.
on mine, I'm trying to, how did you select that? Because when I select that for mine, I try to select the center and I select the edge of the block, then it gives me degrees. It doesn't select the center of the circle, it selects the circle itself.
Okay. So I'm going to come up here to the leader, click on it, press delete. So I will smart dimension. I'll go from the top edge. I'm choosing the edge of the hole.
Maybe that's the problem. Maybe I'm choosing the hole first. I should be choosing the edge first. Oh, is that the problem? No.
It shouldn't really matter.
I don't know why it's not letting me select it. Here, I'll show you.
Go ahead and take the screen, yeah.
All right. So I can go and try to select this, but then it gives me this view right here. And then if I go and try to select this, well,
Yeah,
maybe
I wouldn't go there. I never like clicking on the center marks for dimensioning. I always like to go between solid edges. So zoom right in, please. Okay, so go to the top of the block, down to the solid edge of the hole.
Oh, okay.
There you go.
I think that's what my problem. I was trying to click the crosshairs of it, and do these dimensions want to be lined up right on that pink line as best you can get, or is that
It doesn't matter.
doesn't matter? All right. And I know, like what you were talking about, is almost. I really don't really want to add any more dimensions to this top one because as soon as I do that, then it's going to be redundant of this. Because the only other dimension I could add here is like this dimension or this dimension, or no, or the whole length of it. But I already have that down here, so that would be redundancy, right? We don't want that, right?
Correct. You never want redundancy. However, if I was going to grade this right now, the question I would ask you is, how far left and right should that threaded hole be?
Yeah, because it's not centered.
Correct.
So, okay, I was thinking about that too. Come on. And that's technically not redundancy, right? Because
No,
measuring one.
that is double dimensioning
Yeah.
because the sum of the 875 and the 1.125 sums up to the 2.0.
Yeah.
So you've given the height of that thing twice. Okay, so now that's good. Now you don't have a tolerancing conflict going on.
I didn't know if this would be double dimensioning because you're double dimensioning, or you're putting a dimension to the hole and then also to the hole. But I guess it doesn't matter since you're going from different sides of it, so that's technically
Right,
not
so
double dimensioning.
so what you could say is, let's say you want to imagine that the hole is like the important thing that's the center. And then you want to say, okay, how far over do I go to make an edge? How far do I go the other way to make an edge?
Oh, okay.
You think about it like that.
Yep.
Okay, so the other thing that I would ding you on right now,
So having two isometric views?
that's one thing.
Yeah.
That wasn't what caught my eye though. So your views do not line up vertically. Think about the glass box. So the rightmost edges in that view should line up with each other.
Okay, yeah, I hadn't messed with that quite yet. Actually, the reason I moved this over here is because I was going to ask you about this too. Look, I got this little isometric view up here that's just moving along with it for some reason.
Yeah, so what I would do is I would delete that bottom view. And delete that little isometric that's out of place.
Oh, that's how you did that. Okay, so now I could go off of this one and then do a projected view.
Yeah, project it downward. And then they'll always be locked together and they'll move together and I'll never ding you on alignment.
Okay, that's what I was missing when I was trying to put them in during the class the other day, is that I went up here and
So go up to insert,
click something.
go down to drawing view, up, 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 up. There you go. Project it. Click on the view, drag down, and click.
Oops.
Hit escape. Now try dragging that bottom view around, and the top one should move with it. Yeah, all right, drag the top one around, the bottom will move with it then.
Okay.
That's what you want. You want to make sure those all line up with each other.
Okay.
And also, the bottom view needs to have the hidden lines turned on. Okay, so if you just go to the panel on the left, yep, go down. See where it says display style? That's where you control your hidden lines. Choose the leftmost box. There you go. Now your dotted lines are appearing, and I can see those hidden lines inside the part.
And like you were talking about a center line. Oh, I got a cat. Like you're talking about
they're helpful.
Like you're talking about the center lines. I don't need the center line for this because it's not a cylinder.
Correct.
Okay.
So you can go right up to the top, right up in the command bar, right in the center. There's more to the right. Right, up. There you go. That's your center line one if you don't want to go through the menu system.
Oh, okay.
And then you just choose two parallel lines and it will drop in a center line. There you go.
Well, we don't need that though, right?
Oh, yes, you do need
Oh, yeah,
that.
we do because we need to dimension it this way too, right?
Yeah. Not so much. It's just a convention that whenever you have a cylindrical surface, you always put a center line on it. You know, unless you've got so many of them that it completely obliterates the view. Like back when I was doing jet engine cases, we had times when we would have like, I don't know, 200 holes around the perimeter. If you put all those center lines in, you completely lose the model.
Yeah.
So in those cases, we left them out.
Okay, and would I get dinged for dimensioning this hole on this model and doing a dimension from there to there or here to here rather than going up here and doing a dimension from like say this line or from that line and going up this way would probably be better?
Yeah, doing your dimensioning in the top view would be much, much better.
Yeah, that's what I think. Cool. Well, if anyone else wants to take the screen here. God damn it.
Yeah,
Davis, what would you like to hear about?
I was actually going to take like 10 steps backwards. I still haven't been able to figure out the first step, which is getting my template or format or whatever you call it for the sheet.
Okay, getting your drawing template hooked up and working.
Yeah, exactly.
Okay. So let's see. So let's back way up then, I guess.
Yeah.
So have you created the folders on your system?
Yeah, I think so. So, you know, if you go to my files, hang on, wait, I've got it. Originally, my problem was it was on OneDrive, I think, and then I tried to bring it out, and I got, but yeah, so there's the B-size sheet 2 format file, and then it is. So if I go, file locations. Sheet formats. Well, this is the line I have, but I'm going to delete that for right now and add it again, basically, but just to show. Then I go to Documents, find it, and there's nothing in the folder.
Okay.
So I've selected the folder, but it's weird because it's the same thing that was happening when it was on OneDrive, where it would let me go to the folder, but it wouldn't have any items inside. So I can select the folder.
That's okay, because that's all you're doing. You're just looking for the pathway to the folder, not the contents.
Okay, I just thought it was weird that it wouldn't show any contents in that folder when I looked at it through this. Well,
No,
regardless. So
that completely makes sense to me. If you're just saying, okay, here's a method for mapping to a folder, yeah, who cares what's in it? So
okay,
they just didn't show it.
okay. So then I haven't really gotten past this point either. So I've got here,
Okay.
but I don't know how to go access that or start the whole drawing process, I guess.
Okay. So go on up to File, go down to Make Drawing from Part.
Thank you. We'll see you next week.
Okay, have a good one, Patrick.
See ya.
Okay. So it looked like you were good.
I think it's happening.
Nope. That's so it looks like you don't have the class drawing template in your templates folder. So show me your templates folder, please.
My templates folder.
Yep.
Like document templates.
So show me SW templates 2020 on your local machine.
Okay. Oh, maybe that's still on OneDrive. I don't know. See, that's in one. Well, let's see if I can. Are you looking for that most recent one or the one we set up way back in the day?
The one way back in the day that
Oh,
should
that
be on
might.
your local machine.
Okay, so that might still be. I tried to move this and I failed to figure out how to do it to move it off of OneDrive, but yeah. So this might still be. If I go and make a new folder in Documents or something. And then maybe I can copy it from. Yeah. I didn't realize it was a problem to put it on OneDrive.
I don't know why. For some people, it sucks them right out to OneDrive.
Well,
And
I mean, I don't. Never mind.
yeah, I kept trying to replicate that this summer when I was prepping for the class, and it just wouldn't do it on mine. I don't know what the deal was.
All right, now it's weird because my like original template that I've been using the whole class.
Yeah.
I believe is on my OneDrive, like the folder is on my OneDrive, and it's been working the whole class as being, I think, but I'm not good with this stuff. So let's see. I've got, if I add.
Okay. Go ahead and make the changes, sure. Okay, so the drawing template that I gave you guys, let's put that in your part template as well, because I'm not seeing that there.
Okay, the drawing template, the one that.
Yeah, the one that you got off the class website. So let's go to, yep.
So I think I have that here under the format,
Go to your downloads folder, please. Okay.
I might have moved it from here when I downloaded it.
Okay.
Um,
Then please
the
either,
one that-
if you can
is it
find
this
it,
one?
great.
Hang on. Are you talking about this one?
Nope. That's exactly where it should be. That format should be in the formats folder.
This one right here. This
That one is fine. That one is good right where it is.
great. And the other, what's the other one that you're talking about?
The other one is, so I'll take the screen. What I'm looking for is piece part drawing template.drwdot. That's what I want to put in your templates folder.
Okay. That be under, that's like lesson 10 or something?
Yes.
I don't think I ever downloaded that.
Okay.
Oh, what's this? Okay.
Yeah. So download that. And are you on Chrome or Firefox?
Chrome.
Okay, good. Firefox was adding some weird appendage to it.
This
No.
wants to be in.
No, don't. Let's go back. Yep, there we go. SolidWorks templates. Put it in there. Okay. Now let's go back to SolidWorks. And let's just delete this print. Just get rid of that.
Yeah.
Okay, now let's try making a drawing again. Okay, up at the top, let's go to it's either templates or templates 2020. You've got two of them. Okay, there's piece part template. We're thinking.
Oh, there we go.
All right.
What's this guy doing?
Yeah, you're almost always going to have to rearrange the views. I would just hit delete because it's easy enough to put that back in. How many gigs of RAM do you have in this machine?
I don't know.
Seems painfully slow.
It is right now. I might have a lot of. I got MATLAB running and possibly R as well. So
Okay.
I can quit out of MATLAB. All right, that's my biggest question then. Okay. Oh boy, I've got to go actually. It's 4 o'clock. So thank you very much.
No problem. Jacob, you still on the line?
Yeah, I'm still here.
Okay, so you wanted to see the Stirling engine?
Yep, sorry, I was busy doing something else. I
No,
was doing a little bit of handiwork.
That is all good. All right, so let's get the Stirling engine opened up. And this is going to involve features at the assembly level that we haven't done yet.
Yeah, I'm good with assemblies. I was taught that already.
Okay.
In high school, I was taught in the engineering vocational program. We went over SolidWorks as a big part of our stuff.
Okay, cool. So then this is no big deal for you then.
Yeah, I was stressing a little bit on the exam because I didn't know what we're doing because since the coronavirus hit, actually not even before that, before the end of my senior year or junior actually, I have never built a model before. From the end of my junior year to right now,
Really?
I haven't built a model to a blueprint standard because I during my senior year I wanted to co-op and went to work on the floor for a factory.
Okay.
It was a good experience. It helped me a lot with my modeling.
Oh, absolutely. If you can get out in the real world, that's always the best. Okay, so let me show you this whole features at the assembly level thing. Really, really simple. So all you do is you bring a can into an assembly, and then you just click on Insert, Assembly Feature, and then you've got all of the same kind of modeling stuff. And you put cuts, you put holes, all of that. So for example, I've got a cut extrude that puts the window in. I've got a cut extrude that cuts the top out of the can. That's that one.
Yeah, I haven't learned the cut in assemblies, but I've learned everything else. As in cutting, as in making multiple parts from the same part, as in saving a different part, making the cut afterwards, then resaving that, then putting it as new. Is that the trash guy? That's the trash guy. Sorry. Someone's banging us on my window.
Okay.
Yeah, so I learned not to do that, but instead make multiple parts from multiple save files and put them into assembly at once. I learned the hard
Okay.
way.
So yeah, that's all I'm asking you guys to do. So when I open the can is whole. And this is just like any of those cast pieces that I used to put in a jet engine. And then when we bring it up to the next assembly level, we would take that cast part and we would grind the hooks, grind the faces, grind the important mating surfaces. And doing all of these cutting operations is exactly analogous to what we did to finish castings that go in a jet engine. Okay.
So if you wouldn't mind, would you mind showing me the sketch for cut extrude number 1? That's the window so you can assemble the inside of the. All right. So you just did a little cut extrude there. Then you go to the mid plane, correct?
Yep. So I put on a tangent plane so I'd be out on the surface. I made some nice looking little window, and then I did a cut extrude right halfway through the can.
Yep. All right. That makes sense how you did that.
Yep. And then at the next assembly level, so then in the next assembly level, I bring in that cut top can, and it comes in with all of the cut features. So now I've got an associative bill of material all the way back to the casting.
All right.
And you can see it. So there's my cut can right there, and there's the can component right here. So I know what to buy all the way back to the raw materials.
All right. So how hard will you be on us for the balloon of the piston?
Oh, incredibly hard. I want equations for the folding and rumpling in the breeze as it strokes up and down. And no, dude, it's a balloon. I mean, this is overkill what I'm showing.
All right, so what you got there is a screw, nut,
Yeah,
spacer.
basically, you just want to bolt through the balloon. Everybody that's tried to glue to the balloon so far has had the glue rip off. So I just put a bolt through and I just clamp it with 2 washers. And that gives you a nice airtight seal.
Yeah. The one thing I would say is maybe if you could glue the inside of the balloon to it, that might work, and do the clamping, that might work. But
You are totally welcome to try whatever you like, because again, this is not an engines class, this is a CAD class. I'm grading you on your ability to draw and convey the assembly directions. That's it. That's what I care about.
yep. So I got a couple of drawings over here of the Stirling engine.
Okay?
So all we need to do is to have basically a flywheel to see that we can actually have the disc spinning. Disc, you prefer CD, correct? Because that's what we're getting.
Yeah, there'll be a CD in your baggie.
All right. And the CD, actually, will we be getting the CD for before or after we show you the models?
You got to show me the models first. So
right.
you have to show me that you have a plan for how you're going to use the material. Then I give you the material and you go build it to print.
All right, just double checking because I just want to make sure the CD and all the other parts are down to the 100th of an inch. 'Cause that's
Thousandths of an inch.
What?
Thousandths of an inch. 3
Yes,
decimal
thousandths.
places.
Yep. It's been way too long.
Yeah, I know how that works.
Yeah. Oh, my dial copper came in today. It's the same one that we use at school, so that's nice.
Nice. You will not be disappointed with that thing.
Oh, I know. I've used it in school way too much to get the exact parts in SolidWorks because we had parts we had to model in SolidWorks back in my sophomore year, so we can then create them in real life. Kind of what we are doing for the Coke engine, except it was a catapult.
Okay. Yeah. Good project.
Yeah, we had to make a catapult that accurately shot 10, 15, 20 feet, a small ping pong ball using various materials given.
Okay.
Kind of similar to what we're doing right now, except a lot less complicated.
I don't know. I don't think this Coke can engine is all that bad. And maybe I'm just traumatized from life, but it doesn't seem horrible. I'm trying to figure out what the next project is going to be. Because I've done the Coke can engine for a bunch of years, and I know the files are floating around. So I thought, well, do I have them make like a clock movement, or it's got to be something interesting without being crippling. And that's where it gets hard. And it has to be cost effective. Because we can do these Stirling engines for about $3 a person. And, I can make that amount of money appear from various places. So, okay, anything else for me?
No, that's it. I just want to make sure because next week I'm going to be, according to my, according to my Gantt chart, I need to be able to finish planning it this week. So I just want to make sure I know what I'm building because next week I'm going to start making models.
Okay.
So,
Yeah, I would absolutely encourage you to get on the models just as soon as possible. Because you're going to find that everybody has stuff due at the end of the semester. So the less you have to do at the end, the better.
Yep. And I got my plans over here. I got a list of what I have to build. I already got the Coke can done because I'll just reuse that from the homework.
Okay. Very good.
Yep. That crankshaft shouldn't be too bad. The elbow you already have listed. Should work for all Coke cans, assuming that we did it correctly. And I got 100 on it, so I'm assuming I did it correctly.
Okay. Very good.
Yep. And flywheel, CD. And I just need you the piston, agitator, and piston power with the balloon.
Okay, rock on.
All right. See you next week.
Okay, sounds good. Bye.
Bye.